This is supposed to be our lab class, but unfortunately we've lost quite a few classes for Thursdays and Saturdays. That's why I haven't been able to cover a lot of things in this semester. I'll be using this class, this lab class, to cover some of the theory materials. We've been talking about databases in our class, right? So in this class, I want to show you some implementation of it. And just to give you the context, in our last class, we were talking about ER diagrams and also schema diagrams. So let me bring up a very simple example that we had. Let's say we have a student entity, and in that student entity we have attributes like ID, which is also the primary key, and the name, maybe an address, and a phone number. There can be a lot more information that we retain about students, but I don't really need to show all of them over here, just to give the idea. And they are all part of the student entity. That's what we show with the lines. So the attributes, they're marked in oval shapes, and the entity is in a rectangular shape. That's how we draw the ER diagram. It's a very conceptual diagram. It's not for implementation, not in this format at least. So in order to implement this in database, what we need to do is we create something called a schema diagram, and in the schema diagram what we design is actually the tables. So the student entity will turn into a student table. For all the attributes that we have listed over here, we will also have them right here. So student will have an ID, and this is where we need to be specific. We have to tell the data type. So the ID, for example, can be long, and this is our primary key, so we mark that as well. See, that's why we get ID, and then we have the data type. This is primary key, that's what we see with the underline. Then also we have a name. The type for that is string, but we don't have anything called string over here. We have varchar instead. In varchar, which stands for variable characters, we have to tell exactly the maximum number of characters you may have for a name. If you have longer names than that, it will get truncated. The last few letters will be chopped off. They will be erased. Okay? And this is where I showed you Southeast University's actual database, and we found out the longest name. So if I remember right, we had a student who has 56 characters long name. It's pretty long, right? Just to be safe, let's say that the maximum length of a name will be 60 characters. And depending on your organization or your requirement, things can change. Okay? So we will add that bit in. Now, see, this one says nullable, so it means that we can create a student record who doesn't have any name. It is possible that you don't have any name. But in reality, we're not going to have any student without any name. So you can actually enforce this thing that whenever you try to save a record, a student record in the database, if the person entering the data, he or she doesn't supply the name, you're not going to save that in the database. Okay? If you want to enforce that, you uncheck this thing, and it says now not null. That really means a student's name cannot be null. It cannot be empty. You must supply a name. Okay? So if we apply that, see how it changes. It had a hollow circle. Now it's a filled circle. Let me show you the difference one more time. If you say this is nullable, now this is hollow circle, so it can be empty like hollow. And if we enforce that it cannot be null, then this has a filled circle. So let me give you some more examples, like the phone and address. Okay, The type for this can be variable character. Okay. So maybe like the address can be pretty long. Let's say 255 characters long. All right. So this, yeah, it really depends on the organization. Let's say that we're just creating the student record and we're in a rush. That we assign an ID, we write down the name, but maybe we're not writing the student's address right now. We will update this later on when we get time. Okay. Ideally though, like the address field shouldn't be blank. There should be an address for a student. So if you can leave it blank, then you have this option. And also for the phone field, okay, the type again, we are going back to varchar. Okay, phone number, yeah, you can think that we can represent with integers or long or any such thing, but we have some issues with that. I'll address some of those. Let's just say that the phone character can be 15 characters long at most. If that's an option, and we're also allowing null for that, then that's how we create this table. So the reason why I want phone numbers to not be integers of any type is because we're going to enter numbers like 0, 1, 7, 3, whatever. Right? So if you write it down as an integer, you cannot save the leading 0. Okay? Right away, you will lose this thing. And also, some people would write numbers differently. They would put a +88 and then write that number. They may also put this thing in brackets like this. They may also put a space or a dash perhaps. So there can be many different ways of writing phone numbers, right? And if you want to leave it flexible, that anyone can write their phone number in any sort of way, you should leave it as a string, which is varchar, and that's what we did. Okay. But if you break the phone number into 3 different parts in a sort of international way, that you have the country code, the area code, and then the actual number, then you can use integer for some of those parts. Okay. But I'm not getting into that. Let's just keep it simple. Let's say that our phone number is one field, one attribute. Okay. So this is what we have as an entity. Student is an entity, and this is a student table. The conversion process, what we followed, let me write down the name so that when you go into your database course, or if you're interested right now, you can look up the topic, search on Google for ER diagram to schema mapping. Okay. There is a fixed set of rules. If you follow those, you can take any ER diagram and map that into schema diagrams. Okay. These things, the varchar, the long things, these are not evident from here. You really have to know what you have to use. The data types, we don't know them. But ER diagram, it has 2 things. We have the entities, these are the entities, and we also have relationship. And in the theory class, I was talking about the cardinality of the relationship. We have one-to-one, one-to-many, and many-to-many. There are different types of relationship. So the problem really is that there are some fixed set of rules that tells you that if you have a one-to-one relationship, how do you map that into schema? If you have a many-to-many relationship, how do you map that in schema diagram? Okay. There is a fixed set of rules for that. And if you want to know more about it, you have to study this ER diagram to schema diagram mapping or schema mapping. If you search with these keywords on Google, you should be able to find out the fixed set of rules. In some textbook, it's a 4-point rule. In some textbook, they drop it down in 3. So these are usually covered in database textbooks, or you can find some blog entries for that as well. They're easy to follow. They should make sense. But I mean, it's not a topic for Java, so I can't really go into detail of that. Let us go with a sort of complete example right over here. We're talking about the student entity, and students come to us to study they register themselves into courses. Okay, so for each course we have some attributes. We have the course code, which is our primary key. In our last class I showed you that we can have two courses with the same name or same title, but they have different course code. So course code, that thing is unique, but the title may or may not be unique. Another important thing over here is the credit hours. So let's just call it credits right over here. And then we can join them with lines, like so, right over here. So just as we have created the student schema or student table, we can have a corresponding course table just like that. And right away we have to give the names. So this is the course one. Well, no, sorry, I got lost. Yeah, the name of the table is course, and over here we have code. Code is a varchar, because let's say CSC 2015 we have letters and we also have numbers. And in last class I also said that the course codes, they can be a maximum 8 characters long. In most cases that would be sufficient. So that's the course table. We have started that. That's one attribute. And then we have the title, which is also a varchar, and maybe we need longer space for that. Maybe 100 characters may be enough. Okay. The title of a course shouldn't be null, so I have unchecked that. And also finally the credits, that's double. Okay, we do have a double type in SQL. We also have a float type in SQL. It cannot be null either. Okay, so we create that table. So mapping an entity to a table, that's very easy. You just create a table with the same name. You take all these attributes, create fields like these, but you have to give the data type for each of these. You have to know what are they. Like there is no other way to tell from the ER diagram, because it's a very high level diagram. It doesn't talk about the nitty-gritty details over here. Now in the ER diagram, another key part right here is the relationship. The students, they come here to register for courses. Okay, so that can be a relationship between the student and the course entity. Okay, student, they register for course. Now I answered this already. We have to write it as M and N, which reads like M students will register for N courses, because if you read it from this side, one student can register for multiple courses. And for one course, there can be multiple students. Like for CSC 2016, this course, we have a lot more students, but only few come to the class. So that's what we show with the cardinal video, right? Now you got an answer. What are we going to do with this? Because if you're looking at ER diagram to schema mapping, we know that for each entity we map them into tables, like so. But what do we do with this relationship right in the middle? We don't know about it, and that's why we need to study this thing. But that's a topic of database course. So I'm just going to tell you what happens with M is to N, many-to-many relationship. What happens right here is that if you have a many-to-many relationship, you create a new table in between and give it a proper name. So for example, this is supposed to be our registration table. Okay, and in this registration table we should bring the ID, the primary keys, from both the tables. So to make sure that we understand this right, let me be very specific. We are bringing the student ID, which is of type long. It has to match this one over here. So over here we're saying that this is long, so it has to be long. And yeah, we're not going to allow nullable, so uncheck that. And also the other table, you have to look at that. We need code, which is varchar 8. So that again is not nullable, so we create that, and we have this intermediate table like this. Okay, so for this relationship, this also turns to be a table in ER2 schema mapping if we have a many-to-many relationship. Now, if we have a one-to-many relationship or one-to-one relationship, there is no need to create this separate table. What do you do in that case? Please try to look it up on Google or any database textbook. You should find the rules, and it's quite easy to follow. So what we show over here is that for one student, you may have many registration records. That's why we have 1 and n down here. And also for one course, you may have multiple registration records. So yeah, well, this is hard to control like that. But let me try. So I'm going to plug this one over here with the code, and this n goes down here with the code. Okay. Just so you know the names, because I'll be using them quite a lot. When we're talking about a table, the key that uniquely identifies every record is called the primary key. So this code is the primary key. Okay. For each of us students, we have an ID card, we have a number, right? And no two students will have the same ID number. So the ID number uniquely identifies a student. They may have the same name, but they won't have the same ID. So that's another example of primary key. And I would say that the student ID is a primary key because it uniquely identifies things. Now, I'm using these as labeling purposes, so you know the name. When you draw the diagram, obviously you don't write down primary key because this is very much obvious. The primary keys, they have underlined right here. So that's how you know something is a primary key and the other ones are not. Over here in this table, we don't have any primary key. What we have is some primary key from other table that are coming over here as foreigners. They're not a particular property of this registration table. They belong somewhere else, right? So in that sense, they're foreign. So if you can remember the name, these are called foreign keys because they don't belong over here. Okay. And student ID over here is a foreign key. The course code is also a foreign key. Maybe I have an extra character there. Yeah, so that's taken out. Is this thing clear? All right. So once we know what are the rules for mapping an ER diagram to schema, this is where we start. We draw this diagram first, and once we get some more information about the data type, we go for a more concrete version. This is the schema diagram, and this is actually pretty much ready to be turned into physical tables, actual code that you write to create the tables. You cannot start over here because it doesn't give you the data types. If you have this thing, you can start writing, start creating some tables, insert data, read from there, and everything else. Is this thing clear? So this is the starting point. Drawing the diagrams first. Draw the ER diagram first. That means the top half of this image. That's the ER diagram. And once you have the ER diagram, you take it to the schema diagram. then comes the actual database. In terms of the actual database, you have to choose what database management system you're going to use. Okay. So far, I haven't talked about the database management systems here in today's class. But once you have the schema diagram ready, you get to decide where you're going to implement this thing. It can be MySQL, it can be Oracle, it can be Microsoft SQL Server. There are many different choices. Okay. So, like I said in our class, that I'm going to go for a easy to use and also freely available option. That's going to be MySQL. You can download it for free from the internet. It works on Windows, it works on Linux, it works on Mac, I guess. So it's pretty much easily portable. So just search for MySQL download, and based on your operating system you have to choose one. But over here we're going to pick the community editions. The enterprise editions, those are not free. Okay, you have to pay for those. So if you go for the community downloads, just pick the MySQL community server, and you got to mention the operating system somewhere down here. Yeah, right here. So if it is Linux, you can pick that from there, or if it's something else like Windows or whatever, you can pick it from here. If you're using something based off Debian, you don't really have to come over here to install it. I think it's much easier done through sudo apt get install MySQL server. It's just as simple like that. So you just write it down, and it will download whatever files is necessary. For the Windows people, please try to look for some tutorials. I haven't used Windows in a long time. So yeah, I don't know. Okay, I mean I can definitely install it if needed, but I haven't tried it out. So if you go for Windows, maybe you'll find executables or MSI files at least. Let me just check. Yeah, there are zipped archives and there are binaries as well. So yeah, try that out, or look for some video tutorials. See, the MSI is here as well. It's going to be very easy to install. There shouldn't be an issue whether you're using Linux or Windows. You should be able to install MySQL. So I will leave that part on you, but whatever platform that you're using, please make sure that when you install it, you assign some root password. Root is the admin user, and it should have some password over here. Just create an account so that when you follow the code that I'm writing over here, you can follow the same sort of thing. And you should have some password, right? I mean, this is about managing your data. You're going to enter some data. You have to keep them secure. So why would you create a database management system that doesn't have any account? Right, so if you're looking at this example right here, I want to guide you through the next steps, how you actually create a table. And this is where I'm going to go plain vanilla, that I will write down all the commands so that you can follow over here. Life is actually much easier than that. There are some graphical user interface where you don't really need to know the commands. You will just click on a few things and you'll be able to create the tables, you'll be able to run queries. It's very much possible. Okay? But since we're talking about writing programs, I think it's much easier done if you actually know the SQL queries, because you'll be writing some of those within your Java programs. Okay? So it's a good practice always to know the code behind the scene. Now, the first thing that you're going to do when you create this database is you have to connect to the database. You can connect to a database remotely, or you can access it from the computer it resides on. For example, I have MySQL Server installed on this PC that I'm using right now, and I can use this PC to log on to it, or I could use a remote PC like one of your computers to log on to this. So this is centrally available. The way you connect to a server is you type in the name of the command. That's the client. MySQL. This is the client. This black window is the client. Or if we write Java code, that's going to be a client. The server is something else. You have to give the username, right? I'm going to be the administrator for now, and I have to write -p. So this -u or -u, you follow that with the username. The password over here after -p, you do not write the password. You just hit enter. Okay. Because let's say the password is abracadabra, like so. If I write it like that, it is not the password, right? If I write it like that, then when I write the password, everyone will be able to see that, and that's a really bad choice. So Linux has some sense of security over here that when you hit enter, you get to write the password. The password, I don't know if this is going to work. Yeah, it works. Well, you don't see that. Okay, so when you're connecting to this thing, you won't be able to see the password when you type it. That's a little bit confusing for some of the students. That's why I'm being specific about it. You're not supposed to see the password. Okay? And it's also a good sign that you're not seeing the stars, so you don't know how many characters are being typed up. These are very basic things, though. So first of all, if you're trying this at home, you'd be logging in with a root account, and you shouldn't be using the root account all the time. You should create a separate account to create your databases, to access your databases, because root is the super user. That account has all the access. He can delete or destroy all the databases on this computer. You don't want to use that. Maybe a less privileged account will be better. So the way to start, let me show you. Let's say we are going to work with databases. These are very natural looking commands. If you want to know what databases are already there on this computer, you just say show DBs. Oh, actually, that's for a different DBMS. This is much more natural. Show databases. And as you see, we have a lot of these databases created right here. Is this thing clear? I mean, the reason why we have so many databases is that when we have our lab exam, I create separate databases for each of the students, and I give them passwords so that they can work individually on their databases. But we don't need these. Some of these things I can actually drop them off, but yeah, let me just leave them there. So there are like 137 databases already present over here. To delete a database, I'm going to delete one of those. Drop, let's say student DB. This is a database, so drop database student DB. And previously we had a database called student DB. After executing this thing, if I run show databases again, you see we have one less row. That means that student DB, that database is gone. The reason I deleted that is just because I want to create this again. I want to use the same name. Create database. What's the name of the database? Student DB. So, I mean, this is much easier than writing Java programs. The commands that you're going to write in SQL, they're very much natural. So you just type in what you're going to do. Create database, then the name of the database. So we created that. Okay. And if you look at the list of databases, it would have that thing, like we have one more database. How do we create tables in this database or run queries? That's the question now. So in order to do so, you have to tell which database you're going to use. There are 137 options over here. You're not going to work on all of them at once. So we say we are going to use student DB. Is this thing clear? first step, create database name. The next line, use database name. So once you do that, it says database changed. Now you're going to use this student DB. Okay. I want to know what are the tables already available within that database. Show tables. It says empty set. So we don't have any table. Okay. That's where these things will come into play. I want to create a table for student. I want to create a table for course. I want to create a table for the registration. So all these things are based on the diagram. You need to know how to create those. Okay. Now, in order to create the tables, you say create table name, like so. Create table student. So I guess you have noticed I haven't mentioned this specifically, but all these SQL codes, they have to end with semicolon. This is a must. Okay. For example, if I write show tables and hit enter without the semicolon, it's not going to run. It will expect something else, and that's the semicolon. All right. So let me create this table, one table at least. Create table student. Okay. And I put a semicolon like this, I hit enter, it doesn't work. Because when you're creating a table, it should have at least one column. Okay. So you cannot just create a table like you created the database. Alright, so let us create this table. We can do it in this way. How do we do it? We have to start parenthesis. And within that, we have to define our columns. So what are the things that we need to put in for a student? ID, name, address, and phone. So let us write them down. ID, name, address, and phone. Okay. I hit enter, it doesn't work. The reason it doesn't work because I'm not working with ER diagram, and databases, they need more information. What is this ID? What is this name? What data type are you going to use? You have to be specific. Okay. Name varchar 60, address varchar 255. MySQL doesn't know anything about it. You have to tell us. Okay. So this is where, let's say that ID is supposed to be long, right? We can write it like that, but it's not going to work. There is an error. See, whenever you have an error, it tells you exactly where you have the error. So it's near this long ID. That's where we started having that error. So this is a little bit different. It quite rightly follows the schema diagram. See, the data type is written after the name, just like UML class diagrams. In programming languages, we write the data type first, like long ID. In UML class diagram, we write it as ID colon long, right? In SQL, you don't use the colon. You write the name of the field or attribute, and after that, you write the data type. Is this thing clear? Name is varchar. And we're going to create 60 characters there. Address, that's what? Varchar, and like 255 characters for that. Phone, that's also varchar. How many characters do we have? 15. So that's that. That's the entire statement. Okay. So if I hit enter, now it says okay. If you hit show tables, it shows you that you got one table. Are we clear till this point? Okay. I have missed a few things though, intentionally of course. You see right here, I'm saying that the ID is supposed to be a primary key, it has some unique, but nowhere when we created the table I marked it as a primary key. I said that the name cannot be null, but I didn't enforce that when I created the table. So So there has to be a way to tell them, because otherwise, how are you going to check these constraints, check these rules? So I can alter the table, I can make changes after creating the table. It's easy to do, but I'm not going to push too many things today. So I'll just, what I'll do is I'll just delete this table and create it again. This is going to be easier, but this is not a professional approach. Let's say I got a table, I got 1000 entries. I'm not just going to delete that just to make some small changes, right? There must be other ways of doing it, but I'm not showing it today. You can find it out by yourself, or maybe if I have time, I can talk about it later. So drop table student, that's it, the student table is gone. Let us create this table again. Okay. Oh, by the way, if you're working on terminal, you can use the up arrow and down arrow to browse your history. You don't have to retype the whole thing. You see, the student ID, this is supposed to be the primary key, right? ID is of type long, and it also has to be primary key. How do we write that? Easy, just type it out, primary key. The name we are saying is going to be of varchar 60, that data type, but it also has to be not null. Name has to be not null. By default, the setting is it can be null. So it is as you say it is. So you just type that out, name varchar 60, not null, and that's it. We hit enter. Which one doesn't have a key length? This is interesting. Give me a bit. Let me try one thing at a time. Okay, alright, that works. So I still need to figure this out, but let me describe this. If you type in DESC and then the name of a table, you can see exactly what we got, right? These are the fields: ID, name, address, phone, and this is the actual type that is being used. Oh, I see now. See, even though I wrote long as a type, seems MySQL, they don't have a corresponding long type. They're interpreting that as medium length text. So they're expecting that I put a length over here, but I thought that, I have a long type, which we do have in other database systems, maybe not in MySQL. So that's why we have a problem. So let me drop this thing one more time and create this table fresh. This time around, I will keep it varchar and say that there can be 13 characters for a student ID, which is what we really have, right? So this is going to be the primary key, and now it's not complaining anymore. So let us just describe the student table, and you'll see something new. Under the key thing, you see it's written PRI, standing for, of course, primary key. Is this thing clear? How we create this table? Okay. I'm going to show you two more examples. How you insert data into it, how you retrieve data. So far, what are the things we covered? How we create a database, how we use that database, how we list all the databases, how we see a list of all the databases, how we can see a list of all the tables, how we can describe a table, how we can create a table. So two new things, how you can insert data in here and also retrieve all the data in here. So let us just create some dummy example, right? So insert, this is also very easy, insert into which table? The student table. What are we inserting? We're inserting some values. And we are going to insert values for each of these fields. We're going to insert value for ID, name, address, and phone number. Okay? So values like, the most popular student, let us start with that. Since this is varchar, we have to use varchar, and it can be of any length up to 13 characters. So let me come up with a random ID. That's when we started, 2002, semester 1. So that's 5, 6, 7, 8, 9, 10, 11, 12, and 13. There is a student with ID 1, and let me call this student number 0. And that's him. Okay, alright, so we need an address and a phone number, right? Okay, so all of these are varchar, so we can throw in pretty much anything. So we close the parentheses and put a semicolon over here, and now it says in one row affected. Okay. If you want to insert another record, we can do so quite easily. You just create a new entry over here, come up with a new ID. Okay, that should do. We got two entries over here. And if I wanted to see all the records that's present in the database, that's even easier. Select star from what table? Student table. See? We got that. If I wanted to see only the ID and the name, I just write it down, and that's what we get. ID and name, we don't see the address. Is this thing clear? So far we have covered quite a few things. What I'm going to do right now is I will create an account for you so that you guys can log in from your computer and access this same database, create new tables if you want, insert new data, retrieve data, whatever you want to do. You can try out these examples. Okay. So first of all, how do we create an account? That's one of those moments. I get a blackout. User. Let me see if it works, then I'll explain what I'm doing. Because maybe I forgot the syntax. No, it's okay. So to create a user in MySQL, you write create user, then the username, followed by an @ symbol, followed by where the user is going to log in from. Okay. What am I trying to do? I'm allowing all of you guys to log in from whatever computer you're using. You don't have to come over here to use this thing. That's why I'm using a wildcard, that %sign, that's a wildcard. So it really means this user can log in from anywhere. Identified by, that's the password. So the username is Spring2018 Java, that's the username. You can use any computer within this LAN, and then your password is going to be Java. Okay. How do I tell that this user has all the access in our StudentDB database? We have to say grant all on the database name which is going to be student DB, and all the tables of student DB. So dot star, grant all on student dot star to Spring 2018 Java add %. So that's that. Flush privileges. So it will be in effect right now, and we are done. So what am I going to do right now? I will write down the commands that you need to connect to this database, and I want you guys, all of you, to try this out. Open up a terminal, try to connect to this database and run a few queries. Okay, so let me write them down somewhere. To connect to this database, you'd be writing MySQL -u, the username. What's the username? Java. Okay, you have to write -p for password, but you're not going to supply the password here. You're not going to use the database on your computer. It's remotely hosted somewhere else. Where is it hosted? -h for hostname, and you have to give the address of this demo PC, this PC that I'm using here. And to do that, I need to know the IP address of this computer. How do we find out the IP address of a computer? Sorry about that. What I was asking, how do I know the IP address of this computer? You guys are saying IP config or something else. What's that? Host name dash capital I. Yeah, that's a very good way to find that out. There are other ways to do the same thing. ifconfig, that gives you the same information and a little bit more. But if you only need to find out the IP address, definitely this is a much better option. So the IP address of this computer is this thing, right? So to connect to this one, we'd be writing this out. And it's asks for the password. The password I said is JAVA in lowercase Java, and we are in. So now, if you say show databases, you'd see that there are two databases. We're not going to use the information schema. We're going to use student DB. So how do we do that? How do we use this student DB, not the information schema? Yeah, it's just how you say it. Use student DB. Okay. If you want to see what tables are there, show tables, and you see that we got a student table. Okay. So these are some very basic things I want you guys to try right now. Okay. So let me write these things, and I'm going to be copy pasting stuff into that place. Okay, so this $sign is not something you're going to type. This one means that you're going to type it out in terminal on the shell, and if we have some angular bracket, that means that that's a SQL query. Okay. So maybe in exam you may see some of these things. I prefer to write it in that way so that everything is clear. So we're going to use that, and I want you guys to run some queries like the insert query. Yeah, Racket Sir is going to get mad if he sees that 420 thing. So then we'll leave that as an example. So that's how you insert something into the database, and you don't have to create this table because this is already there, but you can create a table with a different name, and that's also a good exercise. So student is already there, but you can create a new table called student 1 or student 2. Okay. That's not a good example, but it's a good exercise. Okay. So this one is how you connect. This is how you use that database. This is how you create the table. This is how you insert data, and finally, this is how you select particular columns from the table. Is this thing clear? Okay. I want you guys to try this out at least and make sure that you can connect to the database and do all these things, because our lab exams are coming up. Our Java exam is at the end of the theory courses though. Oh, by the way, you may have seen that the lab exam is announced on May 9th. That was the original plan. However, our theory exam is also running on May 9th, so we have to shift this lab exam. It will take place on May 10th instead. For some of you, or maybe for some other students, they will have exams on May 9th, so I cannot have this lab exam on the same day. So that's why I will be holding this on the 10th. But if for some of you that's going to be very late, like if you need to go away from Dhaka, let me know ahead of time. I can arrange for an earlier exam at a convenient date. If for some of you that's the case, let me know. Alright, so with that said, I'm going to stop recording this over here unless you guys got any questions, because I'm not going to add any more things over here. This is just for you to follow right now to make sure that you can connect to the database and do whatever. Anything to ask on this? No? No? I'm here. Try to connect. Let me know if you have any problem so that I can sort it out. So, just a bit.